Okay, so we're starting off with fire safety. So if you have your book there in front of you, if you want to fill it out as we go along, that'll be your homework done. We're starting with 16, which is on page 95 there. So it's fire safety at the bottom of page 95 in your book if you have it. Okay, so for fire safety even, all timbering should be separated from the chimney by a concrete block that has to be at least 200 millimeters. Okay, so you can see in the first image here, the first image is for the first bullet point here. So there's a gap here between the chimney in the center here and the timber. Okay, and that gap has to be at least 200 millimeters. Okay, it's for fire safety. Okay, concrete won't catch fire, but obviously timber will. Okay. Second point, alternatively, a space of 40 millimeters must be kept between the timber and the chimney. Okay, so you can see here, this is an alternative method. Okay, there's actually a gap here between the timber and the chimney area. The idea there is that the timber doesn't actually touch the chimney, so it can't catch fire. Okay. And the final option then for fire safety regarding the chimney construction is that all the metal fixings in contact with the flue, so remember the flue is the part in the centre, the orange part. Okay, and the combustible material is it's a very light grey area here around the flue. So they must be at least 50 millimeters from the flue. Okay, so any metal fixings need to be at least 50 millimeters from the flue. Okay, so as I say guys, this is on the bottom of page 95, so you can just write in the 3 bullet points. You can summarise them into your own words if you want, and you can put the sketches in the space provided. Okay, again, if you don't have your book with you at home, I'll have a PDF up online on Google Classroom for you. Okay. Okay, so this is just kind of a real image of it. So you can see this is your fireplace or your chimney even being built up with your normal concrete blocks. You can see there's a gap here between the timber and the chimney of 40 millimeters, and that will be at all 4 sides. Okay. Again here, it's just another way of seeing it. So this is looking from downstairs, looking up. Okay, so again you can see your 40 mil gap. And again, this is on top of the chimney, or top of the roof, looking down around your chimney. Again, you can see there's a 40 mil gap here. Okay. Moving on to the top of page 96, we're on 17. So we're talking about a party wall. Okay. So what is a party wall? A party wall is a wall that's between 2 neighbouring buildings. Okay. So if you live in a house that's attached to another house, there'll be a party wall in between them. Okay, it's basically just a thicker wall, and the idea is that it reduces noise. Okay. So it's vital that if there's a fire in one of the buildings, so if there's a fire here in house A, say, that it doesn't go straight into house B because they're attached. Okay, so by building a party wall, we want it to be kind of able to prevent a fire spreading from one house to the next. Okay, a space of 200 millimeters must be maintained between the neighbouring flues. Okay, so we'll look at that in a minute. There it is. Okay, so in between the party wall, so imagine this is the party wall, and there's a chimney in house A, or a fireplace in house A, and on the other side of the party wall, house B has a fire. Okay, so the 2 chimney flues need to have a gap of at least 200 millimeters, which you can see here between them. So that's if one chimney was to catch fire, they'd be less likely to affect the other one, unless it was very severe. Okay. And no floor joist should continue between the party wall. Instead, the joist can be hung on steel hangers on each side of the wall. Okay. So in other words, what the final point there means is that the timber joists from house A should not go straight through to house B. They should have separate joists, or that goes for any piece of timber. They should have separate pieces of timber that should not go into the next house in case they do catch fire. And we use a steel kind of bracket that fixes them to the party wall instead. Okay, so the idea is that the party wall is a complete divider between house A and house B. Okay. Again, this is just a kind of real image of the chimneys between party walls. Okay, so there should be at least 200 millimeters between them. Moving on now to 18, which is looking at carbon monoxide. Okay, so carbon monoxide is being described as opposed to the silent killer. So in that section, what do you need to do? You need to explain what carbon monoxide is and how it can be created in your house. Okay, so I'm sure everyone has an idea of what carbon monoxide is. It's kind of a gas that is released from burning fuel mainly. Okay, it's kind of poisonous gas. And the thing about it is you can't see it, you can't taste it, and there's no smell of it. Okay, so just to go through the points here quickly, and you can write them in your book there. When fuel is burned, carbon monoxide is produced. Okay, carbon monoxide is made up of two molecules, so this is kind of scientific here, oxygen and carbon. Okay, it's not too important that we know that. Okay, it's just there for your own learning. Okay, what we do need to know is when fuel is burned and starved of oxygen due to poor ventilation, carbon monoxide is produced. Okay, so if you have a fire in your house, fireplace, and you're burning turf or coal, and the fireplace doesn't have adequate oxygen coming into it, then there's a very high chance that carbon monoxide could be produced, and carbon monoxide would be present in your house. Okay, so it's a poisonous gas, as I said earlier. It can be fatal. And as we said, it's colourless, it's odourless, and it's tasteless. Okay, so you've no idea it's there. And to warn against carbon monoxide, we can get a detector. So maybe in your house you have a carbon monoxide tester or detector, and it's usually on the wall, and it just looks like that there. It's kind of like a smoke alarm. Okay, and if there's carbon monoxide in your house, just let it go off and make some noise. Okay. So everyone should have a carbon monoxide alarm or a carbon monoxide detector in their house. Okay, especially in a room where you have the fireplace or an open fire. Okay, this is 19. So carbon monoxide buildup can be prevented. Okay, so we have 6 steps for preventing carbon monoxide. So we can ensure that all boilers are regularly serviced. So if you have a back boiler behind your stove or your range, okay, it should be regularly serviced. Ensure that the fire has adequate ventilation, so every fire you have should have ventilation. Now an open fire would obviously have ventilation, but if you have a stove or some kind of enclosed range, you need to make sure that there's ventilation getting in. And there is usually mechanisms on a stove that allows you to increase or reduce the amount of air or oxygen that gets into a fire. Okay, install wall vents. So if you did have basically ventilation, so wall vents, or open your windows, you can see that's the next one, window vents, or any kind of vent. Basically the idea of the vent is that some of the carbon monoxide gas would be able to get out of the house. Okay, and at least it would reduce its kind of fatality to the occupants of the house. Okay, and finally there, all homes should have a carbon monoxide alarm in the same room as the source. So the source would obviously be your fire. Okay, so now 20, so we're kind of looking at wind stability. Okay, for the chimney, so how high would we build a chimney? Okay, obviously we don't want it to be too high because there's a risk that it'll catch a lot of wind, especially in Ireland. So chimneys must be designed to withstand the wind. Okay, it goes without saying. The height/width ratio is the most important design factor to achieve this. Okay, so we're talking about the height. When we're talking about the height, we're talking about the height of the fireplace, the back end, okay, usually along the ridge of the house, which is the middle of your roof, the highest point of your roof. And B here is the thickness or the width, okay. Because the wind is different in different parts of the country, a guidance map is used to determine the sizing of the chimney, okay. So in other words, what that point means is, obviously if you live along the coast near a beach area or the sea, obviously it's going to be a hell of a lot more windier than it would be if you lived in, say, central areas or even in the centre of Ireland, okay, the Midlands. You wouldn't have as severe wind, okay. So the map they use, so obviously as you can imagine, Donegal is on the highest end of the scale, okay, being the yellow. Okay, you don't really need to know this, okay, but it's just kind of for your own information. Obviously around the Midlands, they would be the best area, and then even around Dublin area would get less wind, okay. Most of the kind of wind and storms that come into Ireland will come in from the Atlantic, okay. So moving on to, so in your book, actually, just to go back, in your book they actually just wanted you, in the top of page 97 there is actually this map, and they want you to follow the missing information. Okay, so 3.5, 4 and 4.5, okay. So that's just the ratio, alright. Again, it's not too important, and you will never get asked that in the exam, but it's in the book, so we may as well follow it out. Now, moving on to more important stuff, backdraft, so it's on page 97, it's question 22 and 23 I think. So when the wind blows against a roof, it creates a zone of pressure and a zone of suction. Okay, so here you have the wind blowing in against the house from this side here, and you can see that afterwards the wind creates a pressure zone, so it's gone too far there. You can see here now, it'll create a pressure zone. Basically the pressure zone is on the side where the wind is hitting your house. Okay, so that's it there. So obviously this is the stormy side of the house. So you can imagine if the wind's coming in from the Atlantic, from the west, it's going to create a pressure zone. And then the other side you have the suction zone. Okay, so obviously if you were to stand on the suction zone of the house, it'll be a lot more sheltered. Okay, so when the wind blows against a roof, it creates zones of pressure and zones of suction. Okay, so the pressure zone is on the side that the wind is hitting the house, the suction zone is on the sheltered side. Exiting smoke from the chimney in the zone of pressure can be forced back down into the chimney. This is known as backdraft. So I don't know if you've ever heard of backdraft or if it's ever happened in your chimney. Okay, chimneys in the zone of suction can be excessively drafty. Okay, so you can get a draft coming down the chimney, and the chimney must be carefully designed to prevent either problem occurring. Okay, so you don't want either problem, so this is important in terms of the design of the chimney. In other words, this is why the chimney will always be higher than your roof. Okay, it needs to be a certain height above your roof, so that the basically the smoke coming up the chimney doesn't get caught in either zone, so the pressure zone or the suction zone. So you want it to be above, coming out above the roof, so if it does hit any wind, that it's above your roof and it'll blow away. Okay, and you can see here this image, I think it's on 23, so they want you to indicate the zone of pressure and the zone of suction on the three images. So you basically just need to highlight the blue area for the pressure zone and the orange area for the suction zone. Okay, again the suction zone will come up over your roof as well. Okay, that's the suction zone. It's obviously different depending on the pitch of the roof, so the bigger the pitch, okay, the less likely it is to come over to the other side of the roof. The lower the pitch, or if it's a flat roof, it's obviously a lot easier for the suction zone to come across. Okay. 24, the bottom of page 97, so we're nearly done now. Is looking at kind of how we decide on the heights and the ratios for the chimney, okay, especially in terms of backdraft. So to prevent backdraft, the chimney stacks must be built with a certain amount of clearance from the roof. Okay, so basically a certain height above the roof. So the height of the roof will be here at the apex or the ridge. It's your highest point of the roof. For roofs with a pitch that is more than 10 degrees, in other words a roof that's not a flat roof, if the chimney is less than 600 millimeters from the ridge, then the chimney must be a minimum of 600 above the ridge. Okay, so if this chimney here, if we look at the first picture here, just if from the ridge, which is this point here, to the chimney flue, if that is less than 600 millimeters, then the chimney must be a minimum of 600 above the ridge line, which again, ridge line is here, so the chimney flue must be at least 600 millimeters above it. Okay, if the chimney then is greater than 600 from the ridge, okay, so you can see here 600 isn't even reaching the ridge in picture 2, then the chimney must be a minimum of 1 meter above the highest point of contact with the roof slope. Okay, so in other words, the highest point of contact for the chimney with the roof is usually at the back point here. Okay, so it's usually at the back point. Okay, and chimney stacks for flat roofs must be a minimum of 1 meter above the roof. Okay, so if you have a flat roof, this is the easiest one to understand. If you have a flat roof, the chimney stack, when we talk about the chimney stack, it's the entire stack, so the flue will be the highest point, so it comes out at the top, so it needs to be at least 1 meter above the flat roof. Okay. Usually the house, the only difference between, say, picture A and picture B, which by the way you are asked to sketch, I think, in your book, on the bottom of page 97. Yeah, okay, you need to put in the measurements as well. The only difference here is basically how far the chimney is from the ridge. Okay, so if the chimney is fairly close to the ridge, then you get away with 600 millimeters, so not as high a chimney. If your chimney is further down the roof basically and is more than 600 millimeters from the ridge, then you need to have it 1 meter from the highest point. Okay, so in other words, there's only two measurements you need to remember, and that's 600 millimeters and 1 meter. Okay, again, if you have any questions, then I will take them at the end of class. Okay, and moving on now to the final couple of questions. Weatherproofing the chimney. Okay, so to prevent damp entering the house, a DPC, so remember that's damp proof course, tray is used to separate the portion of the chimney above roof level from the internal portion of the chimney. These trays are always made from lead, so if you look up at your chimney, there's basically lead flashing going up the wall of the chimney slightly that connects it to the roof, goes underneath your slates or your tiles. That's just to stop any water coming down along the blocks of your chimney and into your house. Okay, so it's a lead flashing. Okay, these trays are, I already said that's made from lead. Alternatively, you can buy prefabricated ones. Okay, these trays prevent rain from leaking into the house by using a front apron and a back gutter. Okay, so you can see the front part of the chimney, they call it an apron, and at the back they call it a gutter. Okay, and then you'll have soakers then down the sides. Okay, so this is the soaker, it's just lead coming down the sides. Each of these components is built into the blockwork and sealed afterwards. Okay, so this is what it looks like in your house when it's done. Okay, so you can see your slates and you can see your chimney's finished. If you look at your chimney, there should be lead coming up slightly. Okay, that lead will go underneath the plaster here, and it also goes underneath the roof. At the front, the apron comes down over the tiles or your slits. Okay, and you can see here, this is the back of the chimney. It's just kind of showing the construction. You can see the lead is placed down before the slating is finished, or the tiling. Okay, so there will be tiles on top of it. Okay. and that is it finished. So we call it lead flashing. So at the front, this is the apron part. We have kind of our soakers on the side, and on the back we call it a gutter. Okay, and you can see the plaster comes over the top of the lead. Okay, so what is the idea of putting lead flashing on a chimney? It's to waterproof the chimney so that no moisture or rain basically gets into your house or leaks in between the chimney and the roof. Okay, and that's just a 3D image of the different parts again. Alright, so you actually have to label them in your, you have to label these parts in the book. If I go back to it there for a minute. So you need to label these parts in your book on page 98. Okay, so you have the back flashing and the back gutter. You have a DPC tray. You have your soakers along the sides, and at the front you'll have an open flashing. Okay, you also have the side flashing as well. Okay, in other words, the flashing is kind of the first layer, and the second layer then is either your soakers or your back gutter in the back. Okay, so there's two layers. Moving on to the final part, which is 27, you have to label and add appropriate measurements to the diagram given on the bottom of page 98. Okay, so it's basically a detail of a chimney coming through the roof. Again, we'll do all our detailed drawings when you get back to school in 2 weeks or 3 weeks time. You're back. Okay. So you have to label the parts. Them up here first. Okay, so number 1 there is the stepped flashing. Number 2 is pointing to the DPC tray. Number 3 would be pointing to the front apron. So this is this area around here. So 3 is the front apron, 2 would be the DPC tray, and the stepped flashing will be number 1. Again, the missing measurement then that they want you to fill in here is 150, okay? So in other words, from the point of the blockwork coming out through the roof, it needs to be at least 150 millimeters above before the plaster comes down over the lead flashing. Okay. Number 4 then on the other side, number 4 is the cover flashing. Okay, so it's the first layer that goes on. And then the back gutter lead layer will go on top of that. That will be number 5. Number 6 is your tilt and fillet here. Okay, it's just so the water doesn't come back up the way. Okay, this will stop the water from coming up the way, and it also raises your slits slightly. Number 7 is the gutter board. It's just a piece of wood. Number 8 then. Number 8 is this piece of wood in here. It's the batten. Okay, it's just where the lead flashing or the lead gutter sits on. And the final part then, number 9, is your trimmer. Again, it's another piece of wood. Okay, remember the trimmer needs to be at least 40 millimeters from the chimney on either side. Okay, and that's it. Okay. Stop our video here.